All right, here's a solution to the fourth written problem for Math 243. Two different questions here, one dealing with the sampling distribution, one dealing with confidence intervals. So we'll just go through them one at a time. Question one, the key thing to recognize here is that these questions are about the sampling distribution. And you know that it's about the sampling distribution if you get down here to part E. The question is about sample averages. So B, C, and D are just to set you up to do part E. E is really the real question in part one. So the question is about sample averages. It's about the sampling distribution. That's what we need to know about. So before you can answer that question, I'm going to ask you about the shape, center, and spread of the sampling distribution. Right? Shape, center, and spread of this sampling distribution. If you read through the question, you might think that information is given to you, but it's actually not. It's kind of tricky here. All this information here deals with the parent distribution. And understanding the difference between the parent distribution and the sampling distribution is the key idea for chapter 4. This stuff is all parent distribution. And that's fairly important. So specifically, if you read through here, it first tells you about the shape. It's right skewed. However, note that that is not the shape of the sampling distribution that you asked about in part B. That's the shape of the parent distribution. Similarly, it gives you the center and the spread of your parent distribution. The center of your parent distribution is mu, and the spread of your parent distribution is sigma. So that's all the information that's given to you up here in the problem that has to do with the parent distribution. Then you might note that they also tell you that your sample size is 50. So that tells you N, your sample size here. And I think I've now labeled everything that's asked in 1A. 1A asks you for mu, sigma, and N. And these will be the three things that are always given to you in these sampling distribution problems, on the midterm, for example. They'll be explicitly given to you. Mu is 250. It's the population mean. Sigma is 20. It's the population standard deviation. And N is 50. That's our sample size. So that's all the information to ask about for 1A. For 1B, C, and D, this probably could have all been one part. It asks you about the shape, center, and spread. But the thing to note is it's not the shape, center, and spread of the parent distribution, the stuff in blue. It's the shape, center, and spread of the sampling distribution, which is why I'm writing it down here in red. The shape of the sampling distribution is tempting to say that it's right skewed because it does say the words right skewed right here. However, the shape is not right skewed. It's normal, or if you want to be picky, approximately normal. Either way is fine. Wait, that's weird. Why? Well, our sampling distribution ends up being normal for one of two reasons. Either because the parent distribution is normal, in this case it's not, the parent distribution is right skewed, or because this thing called the central limit theorem, which tells us that as long as n is large enough, greater than or equal to 30 in our class, the shape of the sampling distribution is going to be normal. Center, maybe this should be like a colon here. The center has a fancy symbol. It's mu with a little x bar in the subscript. That makes sense. It's kind of like the center was over here, the center for my parent distribution, but it's different. It's the center of the sampling distribution. How am I going to keep those straight? Well, the sampling distribution is talking about sample averages. X bar is my symbol for sample averages. So it's mu, kind of center, you're thinking, of the sample averages. And the nice thing about mu sub x bar is it's always just equal to mu. And mu in this case was 250. So this is the symbol for the sampling distribution center. And I'm telling you that that's the same as the parent distribution center, which is 250. There's also a symbol for the sampling distribution spread. It's kind of like the symbol for the parent distribution spread, except it has an x bar in the subscript for the same reason as it did up here. This one's a little bit harder. This one's not just equal to sigma. It's sigma divided by the square root of n. So in this case, it is 20 divided by the square root of 50. And typically, I just tell you, you can leave it just like this. Although in the specific one, it did say to round to 4 decimal places for some reason. I don't even know why I asked you to do that, but fine. Type it into your calculator. 20 divided by the square root of 50. And it looks like it's telling me that's 2.8284. But I can tell you that I almost prefer this form to this form, so I don't even know why I asked you to do that. Not really that important. There's B, C, and D. Why did I ask you B, C, and D? All to set up question E. E says, between which two values did the middle 95% of sample averages, we're talking about the sampling distribution, fall? Present your answer with a sketch of the distribution. All right, I have all the information to sketch my distribution right here. I can draw it normal, even though it tells me the parent distribution's right skewed. And that's because I'm drawing the sampling distribution, not the parent distribution. In the center, I can put 250 because that is the center of my sampling distribution. I could count up by 2.8284. I just don't want to. I think I told you in the videos you don't have to count up and down by the spreads of the sampling distribution because often they end up being decimals like they are here. And what I want to know are two values that kind of capture the middle 95%. So a value over here and a value over here that captures the middle 95% here. And I can find those two values. You can find those two values using the inverse norm function because that's the only way you knew how to do it when you were back in chapter 4. As we'll see in part 2 of this, there's another way you can do it. You hit second and then variables and go down to inverse norm. The area to the left of the point I'm looking for, if I'm looking for this point right here, the area to the left of it is 2.5%. Where'd that come from? Well, if 95% is in the middle, 5% on the outside. And because the 95% is in the middle, half of that 5% is on the right and half of it's on the left. So to the left of this point is just this 2.5%, 0.025 is how you type in 2.5% as a decimal. The center and the spread are 250 and 20 divided by the square root of 50 respectively. If you type in 2.8284 for your spread here, that's totally fine. I don't care. Probably better to not use rounded values, so use this one, but whatever. If you round it, it's not the end of the world. It's worth pointing out that this is really annoying that it asks me for sigma, but I don't put sigma in. Sigma's 20. It asks me for sigma, and I don't put sigma in. That's a downside to the inverse norm and the normal CDF functions on your calculator. They want the area to the left of the point, and then the center, and then the spread. Not sigma, not mu and sigma. So for this problem, I'm using inverse norm. The area below the point that I'm looking for is 0.025. The center is 250, and my spread is either 20 divided by the square root of 50, or if you prefer, 2.824. Hit paste, it spits out a number. That number is this endpoint, 244. Did I say anything about rounding here? I don't remember. Present your answer. No, it doesn't even say, so let's just keep a few decimal places. Point, I don't know, 4, 6, sure. That seems sufficient. We'll round to 2 decimal places somewhat arbitrarily. You can round it however you want since I didn't tell you. Then we're going to do inverse norm again to find this point over here. I'm going to kind of cheat a little bit rather than retype the whole thing in. I'm going to notice that my dog's drinking water in the background. Sorry, that's so loud. That the only thing that changes is the area to the left of the point. The center and the spread are still 250 and 20 divided by the square root of 50 respectively. But the area to the left of this guy is 97.5%. So this is for this one, and this is for this one. So what I did is I hit second and then enter to pull up the most recent entry, and then I'm just going to change this to 0.975 instead of 0.025. And it spits out this number, 255. Point, I guess for consistency's sake, I'll round to 2 decimal places, 54. That's my confidence interval. Present your answer with the sketch of the oh, this is not a confidence interval, sorry. These are just 2 values that capture the middle 95%. What you'll see in part E is it's basically a confidence interval. Question 2. Question 2, I meant to kind of emulate question 1. In fact, I think the answers are going to be the same. But why I wanted you to do it twice is for you to see the connection between what you do in 4.1 and what you do in 4.2. I'm going to ask you to do both on the quiz. They're not going to be the exact same numbers on the quiz like they were on this problem. Now suppose that in a random sample of 50 country music songs, note that n staying the same, the sample average was 250. I guess I should have said the average length was 250 seconds. Assume that you somehow know that the population standard deviation for country music song length is 20. So note that sigma is staying the same. N is staying the same. And you're not given mu because you're creating a confidence interval for mu. But x bar is equal to what mu was equal to up here. And by making things work out that way, you're going to end up getting the same answers for 2. So 2a asks me to state and justify the shape of the distribution, then state the center and the spread. Sure, shape, center, spread. The shape, good shortcut. It's always going to be normal or approximately normal, whatever you want to write in this class. Because if it's not, you can't use your calculator function. Like, how do you know it's approximately normal? Well, because my sample size is large enough, it's greater than or equal to 30. Because note that n is still greater than or equal to 30 because it's 50. My center, it's no longer mu sub x bar. It's not a population average. It's not equal to mu. It's just x bar. It's my sample average. It's what I put in the middle of my confidence interval. Is what's called a point estimate. It's 250 in this case. And my spread, if you want to use this symbol sigma sub x bar for it, it'd be fine. And really, you could use that symbol up here, but typically people don't. Typically, people just write sigma over the square root of n. And sigma was 20, and n is still 50. Shape center spread looks pretty similar to what it did up here. Sketch a picture showing your level of confidence, the point estimate, and the bounds of your interval. That's exactly what I asked you to do on the quiz. So here's your picture. You want a 95% confidence interval. It states that in the problem. So you want the area in the middle to be 95%. Oh, just like it was up there. Yep. Your point estimate is the center of your confidence interval, which is always equal to x bar, which is 250. Oh, that's the same number that my center was up here. And my spread is 20 divided by the square root of 50. I can find the values that go here and here using the z interval function in my calculator. Hit stat, then go over to tests. Z interval is the 7th thing listed. Tell you guys statistics about the data, and then give it those statistics. When it wants sigma, it really wants sigma because you're giving it sigma and n in this screen. So it'll figure out the spread for you. It's a little confusing. Easy to mess up on a quiz. X bar was 250, and I want a 95% confidence interval. If I hit calculate, note that it gives me the exact same answers that I had up here. 244.46 and 255.54. That's my confidence interval. There was a third part here where it says state your conclusion in a sentence or two. What this means is I am 95% sure, or confident or certain, that the, maybe in parentheses, population average, I think this was country music, song length, is between 244.46 seconds and 255.54 seconds. That's what we just figured out. So quick recap. I know you're like, why'd you do the exact same problem twice? Well, I kind of did and I kind of didn't. In this first one, we were given the population average and we wanted to figure out where x bar likely lies. In the second one, we were given x bar and we wanted to figure out where the where the population average likely lies. Given the population average, looking for the sample average. Given the sample average, looking for the population average. I made the numbers work out so that they're the exact same, but it's really two different concepts, which is why I asked you to do both in this problem.